Hey everyone! In this video, we're going to look at some more properties of limits. Now these ones are going to be a little bit more complicated than our last ones because we are dealing with division. So we're going to look at the limit of a quotient and the limit of a rational function. I want to start off by looking at the limit of a quotient, and I want to take some time to kind of break down this theorem. So there are a couple parts to this. So the first thing is, let's say we are looking at the limit of a couple functions that are being divided. So the limit as x approaches c of f of x divided by a second function g of x. Now, when I'm looking at this, the first thing we need to know is both of these two functions, each of their own individual limits need to exist. So the limit as x approaches c of f of x and the limit of g of x, both of these limits need to exist. So that's the first piece. Now, if that's true, then we can rewrite this. So instead of the limit of a quotient, we can write this as the quotient of two limits. So this is equal to the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. Again, the reason we want to do this is to break down the limit into things that are easier to work with, easier to evaluate. So when I have it like this, now I have the limit of two separate functions, and using all the different properties we talked about before, we should be able to evaluate this. But there is one extra thing. Because we have division, this limit in the denominator, so as x is approaching c, this limit cannot be approaching 0. So as a note, so provided the limit as x approaches c of g of x, this limit cannot be 0. And if that's the case, then we can use this property to evaluate. Now if we go one step further, a rational function, this is two polynomials that are divided. So if f of x and g of x are both polynomials, we should be able to evaluate the limit pretty easily. So let's write down another theorem. So if I have the limit as x approaches c of a rational function, I'm going to indicate that with a capital R. So remember, this is just two polynomials that are being divided. If I apply my quotient rule up here, this is the limit of a polynomial, and this is the limit of a polynomial. We've already talked about the property for limits of polynomials. We can evaluate that just by substituting. So now, if both of those are polynomials, the limit of my rational function is the same thing. I can just plug in that value of c, and we can evaluate our limit. However, again, because we are dealing with division, there is one extra little thing. So this only works as long as c is in the domain. So if we look at our function, our rational function, and we take a look at the domain, if the value of c that x is approaching, as long as that is in the domain, we can use substitution as a way to evaluate that. So let's use these now in an example. So here I'm looking at the limit as x approaches 1, and then my rational function, 3x cubed minus 2x plus 1 all over 4x squared. So the first thing is, let's take a look at the domain of this function. So I'm just going to write this out here. So my rational function is this whole expression. And then I want to know what the domain of this is. Remember, when you're finding the domain given an expression, what you need to think about is what sort of restrictions do you have? So in this case, my one restriction is division. So I don't want to divide by 0. So as long as 4x squared is not equal to 0, everything else is going to be in the domain. So the only thing that would make this equal to 0 is 0. So x cannot be 0. So our domain is everything but 0. So I could say all real numbers except x cannot equal 0. Or if I want to write this in interval notation, I would say negative infinity to 0, and then union 0 to infinity. Okay, so now that we know our domain, we can take a look at our value for c, and this is 1. 1 is in the domain, so we can just use our limit of a rational function property to evaluate this. So all we have to do is plug in 1. So 3 times 1 cubed minus 2 times 1 plus 1, and then this is all over 4 times 1 squared. Again, all those ones are easy to evaluate. So we end up with 3 minus 2 plus 1 all over 4. So 3 minus 2 plus 1, we end up with 2 over 4. So our final answer, the limit as x approaches 1 of our rational function is equal to 1/2. And there's our answer. So again, because 1 was in the domain, we were able to evaluate this by substituting. Now, if we wanted to take a look at the limit as x approaches 0, 0 is not in the domain. If that was the case, we're going to have to apply some different methods to be able to solve that one.